Hi, I'm Chris Poore. I'm a senior reverse engineer at Assured Information Security, otherwise known as AIS. And in this talk, I'll be going over the recent remote sensor node updates to our open source framework called FISSURE. I'll start, for those that aren't familiar with FISSURE, I'll give you a basic overview. I'll try to explain why FISSURE is important, why it could be useful to you, and we'll go over the remote sensor node updates, and I'll spend most of this presentation walking through a video demonstration where I'll show you how to configure the sensor nodes. I'll show you some of the transmit and receive capabilities that FISSURE can do, and then I'll show you how to set up these auto-run playlists for the sensor nodes and set up different types of triggers to kick off different electromagnetic effects. A little bit about me. I'm a senior reverse engineer. I'm part of a team of security testers and other reverse engineers. So I'm coming at this from a cyber perspective, and as FISSURE does more of the RF things, as that gets filled out, it'll lean towards the cyber realm as we develop it some more. A little bit about my company, Assured Information Security. We're a cyber and information security company. We do all things cyber that you could think of. We have a couple hundred people. We're headquartered in Rome, New York. Check out our website, ainfosec.com, to view the different products and services that we offer. All right, so FISSURE is our open source framework. It's on GitHub right now. It's been out for a couple years. It was originally designed to help speed up the characterization of signals and the reverse engineering of RF protocols. It's kind of there to help solve this RF reverse engineering process, and it contains hooks for these different categories in that process, so for things like monitoring, collection, replay, and so on. And so as you go about your daily work and you have these tools and techniques and algorithms, FISSURE is a place where you can put them into software that can be shared by everyone. So it's a work in progress, and as we fill it out, it will be more automated and more complete, but as it is right now, it does a lot of things manually pretty well. It comes with a nice, easy, pain-free installer that installs hundreds of third-party tools. It's meant for beginners and experts. Beginners can learn about different topics. Experts can insert their cutting-edge code. It's written in Python. There's a nice GUI for it. And we're always looking for new contributors and lessons and things like that to add in the framework. So as you hear about FISSURE, think about ways that you could possibly contribute, and feel free to reach out to me. Why FISSURE? As I mentioned, you can stage your computer with hundreds of tools. You avoid starting from scratch. People you work with start from the same proven baseline. It's great for staging up computers from scratch. You can reuse your code, so as you do things in your daily work, it doesn't have to disappear when the project ends. You can contribute and put it inside of FISSURE, and you can access it later on, and you can share it with other people. If you want to learn about different technologies, FISSURE is great for browsing these topics and seeing things. It's very visual, and you can discover improvements for FISSURE, contribute. You can build something, you can advertise it online, you can get famous through it maybe, I don't know. And it's different than working on a project and not getting any recognition for it. I mean, you can help other people as you do this. So share your success, network with other people, help grow a community and grow professionally. Put it on your resume saying you contributed to FISSURE. As we're at GRCon right now, here are some of the important GNU radio aspects. FISSURE is centered around GNU radio. It lets you install all the different auto-tree modules with a single click. You can access the flow graphs and scripts that you like to use, change variables with a couple clicks. You can launch live inspection flow graphs against files or using radios. You can download collections of example signals from our online archive that we're building up. And you can view default variables and tables, build playlists, apply triggers, and we have it backwards compatible with a few GNU radio versions. So FISSURE is intended to solve that RF reverse engineering process. In particular, it has a bunch of tabs that do different things. I won't go into detail about all the tabs, but generally we start out capturing large streams of IQ data, and then we try to isolate those streams into individual files using signal conditioning techniques. And then from those individual files, we do feature extraction to get statistical values that'll help us with AI ML models for classification of things like protocols and emitters. And that isolated data, those statistical features and those classification results can go to the next phase, which might be trying to obtain a bit stream. So you'll have an example IQ file, and you apply techniques to try to get those bits. And you try to get as much information as you can and add it to your library. And then we also have attack tabs for manual analysis. In the future, we'd like to automate all of this, have more vulnerability analysis, discover what something is, and then react to it and see if you've had an impact on the system. It does some preliminary fuzzing, but it's mostly manual analysis right now, and we're going to tie it all together. Here are more tabs, our online archive, the new addition, the sensor node tabs. We'll go through all this. View the library, add things to it, view the logs, access the menu items. All right, so what do I mean by remote sensor node? These are general purpose computers. They support any type of radio peripheral or sensor that you can plug into a computer typically. They run scripted playlists on startup, or they can be controlled through user interaction using the FISSURE dashboard GUI. They save data locally to the remote sensor node, and you can transfer it over the network. You can also transfer data to the sensor nodes. They maintain existing FISSURE capabilities, so whatever you used to do with FISSURE, you can still do with these sensor nodes. It runs a small subset of code, so if you're running it locally, it's the same code that you would run remotely. You just do it on a different machine. And you can communicate with these sensor nodes locally, like I said, over a local network, over the internet. So it's a great way to access different environments remotely. So here's kind of an example of what I'm talking about. You have a laptop that has the FISSURE dashboard GUI. It's connected to a Wi-Fi network. And then you have two sensor nodes. One might be a mini PC with a couple SDRs connected to it. Another might be a single board computer with another SDR connected to it. So this is what I'm talking about when I say remote sensor node. Some of the benefits to this approach: it's low cost, versatile hardware options. You can swap them out based on the mission need. There's flexible software that supports integration. We can use existing computers on your platform perhaps, or you can network to pieces of your software and just pass data back and forth. It's open source. It provides unique levels of access, so you and your partners, your collaborators can all share the software today. It doesn't take that much to get it set up. It's a great education and training tool. It provides remote access for RF testing. I do that a lot in my work, so if I work remotely, I can access devices back at the office, and this is a nice way to set that up. And it widens access to other RF environments, maybe places around the world, special test sites, laboratories. I'll talk about that a little bit more. We set up an IoT laboratory where this is a big part of it. And in FISSURE, and these updates also unlock a lot of geospatial scenarios for FISSURE, like direction finding, tracking, intrusion detection, mobile deployment, perimeter fence. These things aren't in place yet, but with these updates, we can start working towards those. So this IoT lab that I mentioned, a lot of the remote sensor node work that we did falls under this technology accelerator called Orion. It's spun up by the Air Force and a few other partners. AIS is one of them. And if you work in the IoT space or Internet of Military things and you need someone to help you accelerate some technology or something you're working on, I encourage you to check out orionassured.com and contact the people through there, and maybe you'll find something that'll help you out. All right, so now I'm going to start our walkthrough through FISSURE in the video. All right, so before I open FISSURE, I want to kind of show you the installer for it. You just run the install script, and it will It'll open up a little GUI, choose, let you choose what operating system you're working on. It should detect it automatically. And from here, you have different categories of tools that you can install. They're not all required. They're there if you want them. If you click on them, you'll see the code that gets run. And on the right side, you'll see a little verify section at the end. And if it passes the test after installation, the items will turn green. If it fails, it'll turn red. You really only need to do the minimum install, like the top 4 items, the hardware, the compile flow graphs, if you're setting up a new remote sensor node. Everything else is kind of just extra third-party tools that are optional, depending on your needs. But it's a great way to explore software, and you don't have to worry about installing it. If it doesn't work, I'd like to hear about it. The items that aren't checked by default, I don't know how to fix yet, so I could use some support with those. A lot of times they'll just fade away and they change how they install things. All right, so if you want to open up Fissure, you just type the Fissure command from anywhere in your terminal. It'll open up this nice little GUI. And if you've never seen Fissure before, there are different menu items on the top for standalone flow graphs, for tools for different categories of technologies. There's a lot of reference material, online calculators, websites, and most of them will just open up a terminal with an example command of how to use it. So it's a great way to explore things maybe you've never seen before. There are also lessons that I'm starting to add to Fissure. The top ones are the ones that I've made. The ones in the bottom are just links to places that I thought were interesting. I'd love to hear about more of them. There's a user manual that you could access offline as well as online. And let's get into the new updates here. So on the top, there are new buttons. This says new sensor node. If you click it, you can launch a local or a remote sensor node. If you're launching a remote node, you just enter the IP address in the ports and you connect to it, and you can recall different setups, you can ping it. So the remote sensor node right now is running on a different computer. It's running a small subset of code, and I'm using this GUI to detect what pieces of hardware are connected to the node. So you can check different radios, and the idea is to get unique identifiers. So if I run flow graphs, I know which ones I'm targeting. So if you have 2 hacker refs, I need to know which serial number that you're using for it. So you probe it, you scan it, you can guess if you have multiple devices connected, and you're just adding it to the defaults for the different Fissure tabs. I'll show you in a second what it's doing. So you click Add to All, and it goes to all the tabs. And throughout the tabs, there are these combo boxes for choosing the hardware that you just selected there. You'll see the name of the radio and the serial number or whatever identifier. And you can access them in different locations throughout Fissure. So these are some of the places where they ask you to select the hardware. If you need to change between nodes, you just right-click the buttons on the top, and it will toggle back and forth between nodes, between active nodes. If you want to launch a local node, that's what I'm doing here. It runs the code locally on your computer. It takes a little bit for it to kick off, but it's the same procedure. You can check multiple radios at once and click that auto scan, and it will go through all of them and try to find the identifiers. And you can probe them, and it'll spit out whatever custom function you want to use to probe. If there's nothing there, it'll probably be blank. All right, so let's go through some of the transmit and receive things you can do in Fissure. So under the attacks, you can launch single stage attacks. These are just scripts. These are Python scripts, GNU radio flow graphs. You can view the default variables, change them before you run it and while it's running. So I have a lamp there on the right there that I just turned on. It's connected to an X10 switch, like an outlet switch, and it's got a Z-Wave light bulb inside of it. You can do multi-stage attacks where you run one attack followed by another attack. You can specify durations for each one. Here I'm turning the switch off, then on, and then I think I'm changing the colors. I'm I'm changing the duration of each attack right here. So you can change the variables before you launch it, just like the single stage. And then click start and it'll go. Lamp off, lamp on. And random colors. Thank you. This is not live. All right. Next, there are different analysis capabilities in FISSURE. You can view IQ files. You can record within this tab. You can also play back signals. So here I'm going to test the recording. You can't really see what's happening live while it's doing it, but if I press a button on that remote that just popped up on the screen, I can capture a signal and it'll plot it as soon as it's done recording. You can change the sample rate, the number of samples. Pressing the button, and you get something like that. All right. I'm doing it again because the signal wasn't very good. There we go. I think next we'll test the playback. So this is a Z-Wave file, Z-Wave signal that will play back at 900 megahertz or so, and it changes the color of the light bulb to green. Yeah, you can't really see the greenness of it, but it's there. There are also live inspection flow graphs that'll pop up a nice little GUI, so if you want to do a waterfall or something simple like that, that's a great place to add them. If you have your own flow graphs that you'd like to use, I'd like to hear about them. The problem with this on the remote nodes is that it's going to pop up the GUI on the remote node, so we still have to fix that. We have to work on passing the data over the network and prevent that from happening. So here we have our online signal archive with just examples of signals. I think I have like 15 devices or so right there right now. So if I want to look at a key fob, which I'm doing right here, I downloaded it from online, and I can do some initial analysis. I can plot different points in data. I can reuse existing tools. So if I have Inspectrum, I can load it up in Inspectrum. This is good for the capture the flag. So you get the ones and zeros from that or someone else's tool. So if a tool has a command line option, I'd like to hear about it so I can just call their tool without having to reinvent the wheel. Otherwise, I'm going to develop solutions to get the bits from something like this. You could also use the buttons on the bottom to do things like a moving average filter, throw out every other sample, clean up the signal a little bit so it looks a little nicer. It applies to whatever's in the window. All right, so the online archive also lets you do simple replay of signals. So if you want to make a playlist of signals, you can just put the IQ files right there, and it'll send it out on one radio. And okay, this is new. Our sensor nodes have the ability to build these auto-run playlists. They have the option of automatically starting when the sensor node starts. And the way you build them is through the single stage and multi-stage attacks. So if you can also import and export them and copy them over if you want. So here I'm going to show you a single stage attack being added to the auto-run playlist. You just click the button Add to Auto-Run on the bottom, and you can change the duration, the timeouts, delays for individual items. You can also change it for the playlist as a whole. So if you want the playlist to kick off at a certain date or time, you can do that. You can have it repeat at a regular interval. I often have this just changing the color of a light bulb when I go to an expo or something, every minute and a half or something like that. Each item in the playlist will run at the same time in different threads, essentially. So if you want to have two different radios do two things at once and you have enough processing going for your computer, you can do that. It's pretty flexible. If you want to have one thing run after the other, that's where you do the multi-stage. And that's a good solution if you can't run two flow graphs on the same piece of hardware at the same time. It'll complain, it'll give you some errors likely. So a multi-stage attack is a way to get around that. And if you just want to start the attack right from this GUI, you can by clicking start and stop. All right. You can export, import, recall settings. It writes it to a nice little YAML file. You can also do file navigation to the remote nodes. So if you select an active node, you can view different folders on the sensor node. It's not full file navigation, but it's limited to different folders. You can download files. You can download folders. It'll zip them and transfer them over. And you could also transfer files to the sensor nodes and open them up and view them. And delete files on the nodes. All right, so that's a lot of the new stuff for the sensor nodes, but let's talk about the triggers for the different attacks. So the single stage, multi-stage, archive playlists, and the auto run playlists all have these little boxes above them that let you add triggers. And I have different categories like acoustic environment, file system, RF, time, and so on. And so here is a little sound threshold that uses my computer microphone for kicking off an attack. I think I'm just doing random colors. So I'll just yell something in my microphone, and it'll sit there saying waiting for triggers until whatever condition is satisfied. And you can set up multiple triggers, and whichever one is executed first successfully, it'll cancel out all the remaining triggers and go right into the playlist or the action you're trying to take. Let's go through a couple more of these. Yeah, this is just showing that if you want to add multiple triggers, you can just click add, it will show up in that little table down there. And you can delete them through that. The environmental triggers require the internet right now. They use WTTR.in. So if you enter a city or an address, you can validate if you typed it in right by clicking the little validate button underneath it. It'll tell you, it'll give you an answer right away. So before you start the attack, you can make sure you got the right city. Sometimes you don't have to specify the state or the country. Like if you're doing Las Vegas, that's probably pretty good. But sometimes they're duplicate city names. All right, we have networking. We have these RF triggers are kind of interesting. Can't read the exact one that's going on. Okay, this is looking for an SSID, so it uses a Wi-Fi adapter. So you can use this for traditional cyber attacks. Like you listen for a router to show up, then maybe you throw an exploit at it. So this is what it's doing right now. It will it'll listen for that router that's sitting there on the table, then it will do a reboot attack to reboot it. All right. So other benefits to these RF attacks are that you can run GNU radio flow graphs, and you can listen for the standard out in the messages. So if you want to listen for a radio station to show up or a song title, you can do that. If you want to listen for like a button press, you can do that. You can listen for cellular towers. You can use GPS to know if you're within a range of a point or past a boundary. And you just set up your custom settings for whatever trigger you want to do, and it's pretty easy to add. We have instructions on how to do it in the user manual. I think I'm going to end the video right here. It's more the same. You can view the whole extended video online. There's a bigger video that goes along with this, but I want to wrap things up. So back to the slides here. I'll do this. So the outlook for our project, we're looking to complete the roadmap items that are listed on the GitHub page. We want to produce more capabilities and participate in RF simulation events, expand and coalesce the online archive of IQ files, test and improve the code through remote assessments, extend to academia, create some classroom exercises, support new radio versions as they come out, and produce more videos for YouTube and Twitter, and experiment using the nodes in different operational scenarios and integrate more on more platforms. If you want to learn more, check out our GitHub page, go to our website, our company website, follow us on Twitter. I'll be posting videos, and that's all I have for now. If you have any questions, let me know. Thank you.